Hello, this is Rebecca Snyder and welcome to Mthpt-137 online. We're going to go ahead and jump right into geometry, and on Blackboard the book is there, so make sure you get the book. You can purchase it from our bookstore or from somebody else, that's totally up to you, or you can just rent it, I don't really care. In the first section here of geometry, what you're looking in front of you is some definitions. And it's not going to take the time to go through these. You can go through them by yourself. They're all in the textbook. So go through these and define them on your own. You can do that without me. I'm going to show you the part where I'm actually going to use them, and that's this part down here. So I'm going to just go through the examples and show you how to use the definitions that are defined above. So the first thing it asks us to do is to convert between radians and degrees. So one of the definitions up above talks about how do we measure in circles, how do we measure angles, and angles themselves, we're used to measuring them in degrees. 360 degrees in a circle, 180 degrees in a triangle, 90 degrees in a right angle, and so on. Well, there is another way to do it, and another way to do it is called radians, and I have also uploaded a short video that shows you how they came up with radians. We're just going to go through how to convert between the two. So one of the ways to do it is to use a proportion. So let me grab my pen here. So what I'm going to do here is the proportion is D for degrees. Let's go back down. It jumped up on me. Okay, D for degrees over 180, because there's 180 degrees in a half a circle, equals R for radians over pi, because there are pi radians in half a circle, and that is talked about in the video. So what we're going to do is, depending on what we're given, we're either going to replace the D for degrees or the R for radians, and then we're going to use the principles in a proportion to solve for the other unknown. So in the case that we're given here, I have 4.3 radians. That 4.3 goes in the R spot. So I have D over 180 equals 4.3 over pi. Now, if you remember, to solve a proportion, what we do is we cross multiply. So I'm going to take 180 times 4.3 and D times pi. So you can kind of see the multiplication symbol there. So 4.3 times 180 equals pi times D. So according to my calculator, 4.3 times 180 is 774. And then to get D by itself, we have to undo the multiplication. So we're going to divide by pi. I definitely would prefer you actually use the pi symbol on your calculator. And if you don't have a calculator with one, you're definitely going to want one. So 774 divided by pi is approximately 246. So in this case, 4.3 radians is approximately 246 degrees. And make sure you put the degree symbol. Okay, so on number 2, this time they give us degrees and they ask us to switch to radians. The proportion doesn't change, and that's the nice way about this thing, is you don't have to change up what you're doing. You just change where you put the numbers that they give you. So 21 in this case is a degree, so it's going to go in the D spot. So it's 21 over 180 equals, I'm looking for the R for the radians, over pi. This part doesn't change, I'm still just cross multiplying. So I have R times 180 equals 21, oops, that's a bad one, times pi. So 21 times the pi symbol, so R times 180 equals, it's approximately 65.97. Now I do go ahead and leave that in the calculator as is, and I'm not going to mess with it. I'm going to go ahead and leave it and then do the division. So I'm going to now divide by 180 So let me show you real quick what I'm talking about. See if I can get my screen to work. So on my calculator you can see I have the 65.97. I'm not going to take that away. I'm just going to now divide, and I'm dividing by 180, so I'm going to hit the division symbol. So I'm going to divide by 180. So I didn't change anything, I just left it in there. So this is the most exact answer I can get, and that's always the best thing to do. So now I know that my R is approximately 0.37, and there is usually going to be some rounding. Now, if you don't put anything behind it, that is radians. Some people that really bothers not to label with something, so if that bothers you, just write RAD behind it, and that'll also mean that it's in radians. Okay, so 3 and 4 aren't any different. The only difference that 3 has is that it's a pi over 3 in our problem, but it doesn't mean we do anything different. This pi over 3 is in radians, so I'm going to do it the exact same way I did number 1. It's just going to look a little bit funny when I set it up. So I'm looking for the d, so it's d over 180 equals, now pi over 3 is my r. So it's pi over 3 over pi, and that's why it looks a little bit funny. Now the process is still the same. 180 times pi over 3, d times pi. So d, so I'm right here, times pi, 180 times pi over 3. Now I'm just going to put all of this in my calculator in one fell swoop. 180 times pi equals, divide by 3 equals. So I have d times pi is approximately 188. Again, I'm not going to plug that back in. I'm going to leave it in my calculator, and I'm going to divide by pi. So that number, 188.4955592, divided by pi, it's always crazy when that happens. You get big, long decimals, and all of a sudden you have 60 degrees. So by doing it exactly, notice how nice that was. If I would have rounded along the way, I wouldn't have got that exact answer of 60 degrees. Now I think I'm going to skip number 4. It's done exactly the same as number 2. These are the same process, and there's really nothing different or fantastic about them. So I'm going to go ahead and skip number 4. So going down to number 5, again, it's working with some of the terminology. We have the term supplement. Supplement was when two angles add up to 180, and it could be more than 2, but we're just dealing with 2 in this case. The other term was complement, and complement is when they add up to 90. So the first thing I'm going to do is find the supplement of the 39-degree angle. So I'm going to do 180 minus, and this is part A, minus 39. Well, 180 minus 39 is 141. So I already have my answer in degrees. 141 degrees is the supplement of 39 degrees. So I'm done with that. Now to find my answer in radians, I simply have to convert 141 degrees to radians. So I'm going to do the same process I just got done doing up above. So d is 141 over 180, because that's how many is in half a circle, equals, I don't know the radians, that's what I'm looking for, over pi. Now you might be asking yourself, why am I using half a circle? You could use 360. If you wanted to, this would be 360, this would be 2 pi. Because if half of a circle is pi, then I must need 2 of them to do a full circle. So that doesn't matter. This is just the smallest numbers I could use. So I'm going to go ahead and multiply diagonally. So 180 times r equals 141 times pi. 141 times pi is approximately 442. Actually, it'd be 443 if I was rounding, but I'm going to leave the number in the calculator. Now I'm going to go ahead and divide it by 180 to get r by itself. So my radian measurement is going to be that number divided by 180. So my radians is approximately 2.5 radians, whether you write the rad or not. Okay, so I've done A and B. Found it in degrees, found the supplement in radians. Okay, number 6. Number 6 is saying find the value of, that symbol is theta. It is a Greek symbol. It's used a lot when we're dealing with angles. I'm going to go ahead and blow this up a little bit so you can maybe see that a little bit better. Okay, so what we know is right here, theta equals pi over 3. This is theta divided by 2, and this is 90. So I can think of a couple ways to go about this. Honestly, the easiest thing to do is know that if theta is pi over 3, and this is wanting us to find theta, oh, I already know it. That is a simple, silly question. Well, let's change the question up. Let's find the value of, let's just say this angle is pi over 3, not that it's theta is pi over 3. And I know that theta over 2 is this angle. This is 90 degrees. Now, pi over 3 is in radians, so this is 90 degrees, which is pi over 2 in radians. And the reason I know that is because 90 is half of 180, and then half of pi. Pi over 2 is half of pi. So what we can do is figure out what is this. So I know that a full circle, or sorry, a full triangle is 180 degrees or pi radians. Well, I know that this angle is pi over 3, this angle is pi over 2, so let's find this angle. So I'm going to do 180 minus pi over 3 minus pi over 2 and see what's left. So 180 minus pi divided by 3 minus, oh, I should not have done 180. See my mistake? Might as well let you know right off the bat, I'm not perfect. Okay, this should be pi, because that's how many radians are in half a circle. Okay, or a triangle. So what we're going to do is we're going to go pi minus pi divided by 3 minus pi divided by 2, and I get 0.52 blah blah blah. Okay, now this is not theta. This is theta over 2. So what I know is theta over 2 is 0.52 approximately. So if I want to find theta, I got to get it by itself. Right now it's being divided by 2, so I'm going to multiply it by 2. I'm going to double it. That'll get rid of the 2's, and I'll just be left with my theta. So I take my number in the calculator, times it by 2. Theta is approximately 1.1. Nope, 1.0. Now, if I would have rounded to 2 decimal places, it would have been 1.05. Unless they tell you what to round to, you get to make your own choice. Just make sure you round appropriately. Okay, so we made that problem work. So this one says find the missing angle. This one is written in degrees, so it works the same except with the 180. So we're going to do 180 minus 82 minus 55. 180 minus 82 minus 55 is 43 degrees. Okay, that was not too bad. So this one says find the length of the missing side and find the area of the triangle. So when you were doing your definitions up above, one of the things you worked with or wrote down was the Pythagorean theorem. The Pythagorean theorem talks about anytime you have a right triangle and this side opposite of the right angle is the hypotenuse, the other two sides adjacent or next to the right angle is the legs, and the Pythagorean theorem helps you find a 1 if you're missing one of the 3 sides. So the Pythagorean theorem is a squared plus b squared equals c squared. Okay, so what we're going to do is a is 12. So we're going to plug that in. So I have 12 squared plus b is 8 squared. So I have 12 squared, that's 144. I have 8 squared, that's 64. 144 plus 64 is 208. Now to undo a square, the inverse of squaring is square rooting. So I'm going to square root 208. And so C is approximately 14. Now I went ahead and rounded to the whole number because my 8 and my 12 were whole numbers, so that's why I did that. Obviously, the less you round, the better answer you'll get later on. So I know that. So now it wants me to find the area of the triangle. Well, the common formula for area of a triangle is 1/2 base times height. And so the base is the part that it's sitting on, and the height is the straight up and down. So this would be the base and this would be the height. So my area would be 1/2 times the base, which is 12, times the height, which is 8. So half of 12 is 6, 6 times 8 is 48. So my area is 48. I don't know the units, so I'm just going to write 48 units squared, because remember, area is always squared. Okay, so that's how I find the formula for, or the area of this. Now, it didn't ask me for the perimeter, but you will have a few of those, and up above it talked about the perimeter is simply when you add up all the sides. So I would simply add up A, B, and C, and that would be its perimeter. Now let's look at 9, which is the last one we're going to look at right now. And it wants us to also find the area of the triangle, but notice I don't have a height. And I know that because the height is always the straight up and down. So think about when you're a kid and somebody was trying to measure and they're like, oh no, stand straight, stand straight. So height is always straight up and down, and I don't know that. So I can't use the traditional or the common method of 1/2 base times height. I'm going to have to figure out another way. And the other way is called Heron's formula, which is another thing you should have written down. So Heron's formula has two parts. First is this letter S. S stands for semi-perimeter. So what it says to do is take half of your perimeter, which is simply your 3 sides added together. So in this case, it would be 12 plus 22 plus 16. Order doesn't matter. So that's going to be 25, and I do know that it's in meters, so that's my S. Now that formula itself, once I know S, is take the square root of S times S minus A times S minus B times S minus C. So S we already determined was 25. And again, order doesn't matter who's A, B, and C. You just want to make sure you do all of them. So it's 25 minus 12 times 25 minus 22 times 25 minus 16. Okay, so 25 times, the first one would be 13, times 25 minus 22 is 3, times 25 minus 16 is 9. So I end up with the square root of 8775. I'm going to go ahead and square root that. And so the area of this triangle is approximately 94 meters squared. So it's not that it's hard, it's just you have to know the formula and you know how to plug it in. So that's the end of this first section. In Chapter 3, we'll have plenty more videos as we go along. If you have any questions, please make sure you email me or call me during my office hours and we'll get those taken care of. Have a good day.